Number 6, part 1, this is learning. Part of it we've already studied under agents, and now we continue with the rest of the concepts. Now the first concept that we need to talk about is the learning agent. Now please understand, for all these theory based topics you will find the descriptive solutions, the descriptive answers in the study material provided to you. I'm just discussing the concept. Now what exactly is the structure of a learning agent? See, learning agent is not something new for you. We've already discussed this at length when we did intelligent agents. You can go through that, or maybe I'll continue here as well. Now what is a learning agent? We all know that agent is someone who represents a business process or can act on behalf of someone. Now over here, these learning agents, they'll accept the information from the environment in the form of percepts. The sensors will then receive the information. The performance element eventually has to decide what is the action that needs to be taken. Now, the reason why these are called as intelligent agents is because as this agent keeps working, the critic will keep on analyzing the database, will keep on analyzing its performance, and it'll keep on giving its feedback, saying whether it is good or whether it is bad or how it is going. So the performance of this learning agent is analyzed at all times, and the performance is being tracked, and the feedback is being given on continuous basis. So it is possible when the agent is generating a solution, in the middle of that also it can change certain strategies, it can do something which can actually improvise the solution. Now as the critic keeps on giving its feedback, the another important component for us is a problem generator. Now what exactly is a problem generator? For the solution to be generated, the problem generator will keep on checking for the other options, or you can say will keep on checking the better ways of doing the same thing. So the problem generator will keep on giving suggestions using which the performance element can actually go and take up something new, or take up a new action or new way of doing things, which can lead to a better experience, or you can say which can lead to a better performance. So it is quite possible that the learning agent might not do the same thing the same way, say if it does that multiple times. So last time if it had used, say, method A for solving a particular problem, now it might use method B because the problem generator and the critic put together have given him the information that this could be a new and the better way of doing the same stuff. So that is what your critic will give you, that is what the problem generator will give you. The learning element will pass on the information to the performance element. The performance element will use the help of all these components before it makes its decisions and informs the actuator about what needs to be done. Needless to say, learning agents are some of the most powerful agents that we can have, because they can generate the desired efficiency, they can generate the desired consistency, and they can generate or improve their performance at all times. So learning agents are the best suited in the environment which is not entirely predictable or which is not entirely observable, because they can keep on performing and they can continuously keep on improving their efficiency and performances. Now, for the detailed description of what I just said, you can go to the study material, go through the learning chapter, and you will find all these things. The next concept that we need to understand is inductive learning. See, talking of inductive learning, a lot of times students tend to find this a bit difficult, because a lot of times the students tend to complicate it for themselves. It's not at all complicated. Let us understand what is inductive learning. Please understand this. Now first and foremost, understand the meaning and the difference between deductive reasoning and inductive reasoning. I guess this will solve your problem to a large extent. Deductive reasoning. Now look at an example that I've given you here. Now over here, suppose if I give you some facts. When I say facts, what it means is that there is no doubt whatsoever regarding whatever I'm telling you now. So the first fact is, I have a holiday every Sunday. And then I tell you that today is Sunday. Now in deductive reasoning, you can come to a conclusion saying that today I have a holiday. Now this is basically what you have deducted from the information given to you. And obviously if both these are facts, if both these are true, in that case the conclusion that you made has to be true. Later on we'll see that systems like expert system and stuff, they'll use deductive reasoning. They are coming to a conclusion looking at the facts given to you. Inductive reasoning, on the other hand, will work in a totally different fashion. What it will do is, it will collect all the evidences, and looking at all the evidences, it will put everything together and come to a hypothesis which might be true looking at the evidence that we have. obviously, moment I say that they are hypothesis, moment I say that there are some suggestions, I cannot be 100% sure that they are correct. So though I can design a hypothesis based on the evidence that I have, evidence always suggests things. They do not conclude things. So the hypothesis that I derive, they might be correct in some cases, they might not be correct in some cases. But you can say I can still come to some kind of a conclusion using inductive reasoning. Inductive reasoning is what is also called as inductive learning. I learn and accordingly I use induction. In simpler terms, induction is the discovery of rules from the data and deduction is application of the rules to come to a conclusion. Talking of inductive reasoning, please understand this. Our aim here is that we have some evidence available to you and we need to find a function, say h, which is the hypothesis, which can be made from the evidence available to us. That is what is the whole idea behind inductive reasoning. Now, talking of hypothesis, see, based on the evidence, coming to a confirmed conclusion is very difficult, but then we can always come to a hypothesis which can be a good approximation. You cannot take this hypothesis as a rule because this is what the evidences are suggesting. The moment I use the word suggesting, what it means is they are not conclusive. So you can use them as some kind of indicators in your reasoning, but you cannot take them as conclusion. Now over here, there are different ways of implementing inductive reasoning. Let's look at some examples. Now, as an example, suppose if I have plotted a graph which is x versus fx, where I have plotted the points which represent the data or which represents the evidence that I have. Now my job here is to come up with some kind of hypothesis on which I can fit most number of points that I have over here. Now I don't know how many points I will be able to put together, or maybe how many hypotheses will follow, say the maximum number of points over here. More the number of points that my hypothesis can follow, that means more evidences are suggesting something to me. Let us see the different ways of doing it. This is one way. Now over here, if I can come to a hypothesis wherein I can get a function which consists of linear segments. If you see, I have all straight lines available over here. Now over here, it is the important part is I'm getting linear segments and it goes through all the points. Now if I can get something like this, this is easy to calculate. But then over here, if my hypothesis is going through all the points, you can say that the predictive performance is moderate because over here I have made conclusions. I have tried to get an hypothesis which passes through all possible points, which might not necessarily be true. The another possibility is where I incorporate or I represent the hypothesis as a polynomial function. Now over here, one thing is for sure, that there won't be any discontinuities. If there's any discontinuity, then it becomes a different discussion altogether. Now, but if there are no discontinuities, I can say I've got a hypothesis which is, say, more predictive or which is more accurate as compared to what I just saw. But when it comes to calculating this, compared to the previous slide that we saw where we had linear segments, this is slightly more difficult to calculate. Then we have something like this, which you can say is the easiest of them all. Over here, we just come to a hypothesis and represent it as a linear function. One of the easiest ones to calculate, one of the easiest ones to represent, but the predictive power is extremely low. So this is how we can actually plot the evidences and then try and derive the hypothesis out of it. So this is inductive learning. Now, as far as examination is concerned, whether it is learning agents or whether it is inductive learning, you can expect them as theory questions in your paper for anything between 4 to 8 marks, depending on the nature of the examination that you're taking. At the moment, thank you for learning with junkminds.com. This is the end of the part 1 of this particular chapter. Meet me with the next part where we continue with more learning methods. Thank you.